Today we're looking at Introduction to Quadratic Functions. Let's start off with a real-world example. Let's suppose a rock is dropped from the top floor of an 800-foot tall building. A camera captures the distance the rock traveled in feet after each second. And we have the first place at 0 seconds it falls 0 feet. At 1 second it fell 16 feet. At 2 seconds it fell 64 feet. At 3 seconds, it fell 144 feet. After 4 seconds, it fell 256 feet. And after 5 seconds, it fell 400 feet. How far will the rock have fallen after 6 seconds? So we just need to kind of show our reasoning. There's a table here with all of the information that you might find helpful. So when I'm looking at this, I want to think, what is the greatest common factor of all of the distances? So if I'm looking at this, I have just 0 is just 0 at the beginning. And then after 16 feet, I have 6, I'm just going to write 16. Now, if I look at 16 and 64, 16 goes into 64 4 times. So 16 times 4 is here. Here we have 16 times 1. Here we have 16 times 0. 144 is 16 times 9. And 256 is 16 times 16. And 400 is 16 times 25. Now, do you see a pattern here? First, we have a 1 squared. Here we have 2 squared. Here we have 3 squared. Here we have 4 squared. And here we have 5 squared. So after 6 seconds, it would be 16 times 36, which is 6 times 6. This is 576 feet. After t seconds, we could put any number in. It would just be 16 times t squared. So our equation after t seconds would be, with d representing the distance, our distance would be equal to 16t squared. And this is the equation for any falling object and how far it falls after a certain number of seconds. So Galileo Galilei, an Italian scientist, and other medieval scholars studied the motion of free-falling objects. The law they discovered can be expressed by the equation d equals 16t squared, which gives the distance fallen in feet as a function of time in seconds. So if I have the equation d equals 16t squared, after half a second, I could put a half in here. So 16 times 0.5 squared, and this will be 4 feet. So if we're trying to figure out how long it will take to hit the ground, if it's 576 feet off the ground, if it's going to hit the ground, total distance traveled will be 576. That will equal 16t squared. So what we're going to do is we're going to get t alone. So the t is being multiplied by 16. So what I'm going to do is I'm going to divide 576 by 16. So that equals 36 feet equals t squared. So our t has to equal 6 seconds. So a cannonball, if is shot off the ground, it's 10 feet off. A cannon is 10 feet off the ground, and it launches a cannonball straight up with a velocity of 288 feet per second. Velocity is another way of saying speed. Imagine that there's no gravity and the cannonball continues to travel upward with the same velocity. So we're going to complete this table for the different heights of the cannonball at different times, and we're going to let h represent the height in feet and t represent the time in seconds.
Did you mess up?
So if I start at 0 seconds, the cannon is 10 feet off the ground. So at 0 seconds, we're starting at 10 feet. But then every second is going up another 288 feet. So after 1 second, we take 10 feet and we add 288 feet, which would give me 298 feet. After 2 seconds, we're going to add another 288 feet because it's another 288 every second. This gives us 586 feet. We add another 288 feet. Okay, so we have all of these heights, but now we're going to write an equation for the model, the height in feet. So if I take my h, we're going to be talking in terms of t. So we, instead of y, we're going to put h of t. This is representing the height in terms of seconds. And we are going to start off with 10 plus 288 times how many seconds in how much time in seconds. So this would be the equation if there was no gravity. It would just keep going up and up and up. But as you know, when you throw a cannonball up in the air, it goes up and then it comes back down. Okay, so this is going to be the actual heights when it went up and came back down. Now we're going to compare these two values in the table, and then we're going to make an observation. So first thing we're going to do is we're going to graph all of these points. But when it's a straight line, we don't have to graph all of them. We just need to start with a couple of them, and then we will just connect it with a straight line. We're going to start at 10 at 0 seconds. So it's going to be very low. And then at 19 seconds, it goes up to 5,482. So that's off our graph. So let's go to, it goes up to 4,500. So let's go to 15 seconds at 4,330. And we're going to have to just kind of do an approximate number. And then we're going to take a line and we're going to connect the two dots. So if there was no gravity, it would just keep going straight up and it would add the same number every time. But now we're going to go ahead and take these actual times and we're going to graph them. So this is what actually happened. So we're going to start at 10. At 1 second, it's going to go to 249. So it's kind of up close to the same there. At 2 seconds, it's going to go to 522. 3 is 730. 4 is 906. 5 seconds will be just a little over 1,000. 6 seconds is 1,162. And at 9 seconds, it's 1306, sorry, 1290. And if you look at this, if you notice, it kind of peaks out at 9 seconds, and then 8 seconds and 10 seconds have the same value. So we have 1290 and 1290, and then it goes 1242 and 1242. So it's kind of reflecting back the same values. So 9 seconds is 1290, and then, or 10 seconds, 1290. 11 seconds is 1242. And then at 18 seconds, it's back at 10. And then just slightly after 18 seconds, it hits the ground. So what happens is it goes up. And then it comes back down. this shape is called a parabola, or sometimes it's referred to as a quadratic. So it is the effect of gravity on an object, and it starts going up because of the velocity, but gravity pushes it down at the same time. Okay, so the graph representing the height of the cannonball with no gravity is a linear function. And the graph representing the actual height of the cannonball is a quadratic function. And this shape is called a parabola. Okay, so we're going to write an equation to model the actual height in feet. So we started we started at 10. And then we added 288 feet every second. Times how many seconds? But remember, it's going down. The height, the value of the function going down, we learned, was 16t squared. But since it's pushing down, we're going to put a negative number with it, so it will make it go down instead of going up. Minus 16t squared. So it's, instead of counting how far it went, we're going to subtract that number from the 10 plus 288t. Okay, so this is our height in terms of time. Now, if we wrote this in standard form, remember we put the highest power first. H of t equals negative 16t squared plus 288t plus 10. So this would be the equation of the cannonball. Okay, so 50 is going to be the height, the initial height of the cannonball. 312 is the initial velocity. And negative 16 is the effect of gravity on the cannonball. For our x values, we're going to put that in for our t. So instead of t, we're going to put an x. We're going to go between 0 and 25, and for the y, we're going to go between 0 and 2000. And this is what that graph looks like. So if you see, it starts about 50 feet off the ground. It goes up until it's over 15,000. And I can actually find that vertex. It peaks out at 1,571 feet at 9.75 seconds. And then it comes down and hits the ground just shy of 20 seconds. Okay, so the graph looks like an upside down U. And it goes up, the graph goes up, and then comes back down again. Okay, so we're estimating the maximum height. When I look at that graph, it's estimated at about 1,571 feet. And it happens just before 20 seconds. Okay, so the domain is how long it takes for it to hit the ground. So we're going to start at 0 seconds, and then we are going to go until just short of 20 seconds. I can find out exactly on here. That is 19.659 seconds. Now when we do domain, we're going from 0 to 19.659 seconds. I'm going to say bracket. This bracket means that is included in the graph. Okay, so we're going to put 2 brackets around here. Now for the range, this is the domain. It's going between, the x's are between 0 and 19.659. And our range, we're talking about y values. And y, this is the only time we read a graph from bottom to top. So we normally read a graph from left to right. So on the range, we're gonna start at 0, and then we're going to peak at 1571. So we're gonna start at 0, and 0 is included in the graph, and then we go till 1571. Now these have brackets because those numbers are included in the graph. Now we're going to just look at some key features of the graph. We're going to be looking at our x-intercepts and our y-intercepts. Now we have our standard form is this top one, and it is written from left to right, from highest power to lowest power. And then when we factor, this is an easy blue factoring, where first we learn to add, then we learn to multiply. So 2 numbers that multiply to 3, add to 4 are 3 and 1. So this factors into x plus 3 and x plus 1. So we've got, if I look at my intercepts, right here I'm looking where the y is 0. All along this, the y is 0. So if I put a 0 in here, I can make my I use the 0 product property. Either this first one has to equal 0, or the second one has to equal 0 when we have 2 things multiplied to equal 0. So I'm going to say x plus 3 equals 0 and x plus 1 equals 0. And then I minus 3 from both sides and minus 1 from both sides, and x will equal negative 3 and x will equal negative 1 as my 2 intercepts where it's crossing this x-axis. Okay, so we have the points, x-intercepts would be negative 3, 0, and negative 1, 0. Now the y-intercept is this number right here. It's our starting point. Now this 3, this is where the starting point is, the plus 3. So I'm going to start right here at 3, and we get this in standard form. So standard form is a great way to find our y-intercept, where intersect or factored form is a great way to find our x-intercepts. Okay, so our domain on parabolas, unless it's an actual real-world example, we're going to say that they go on forever. So we're going to say, we could say all real numbers. Another way of saying this in interval notation is from negative infinity to infinity. Now our range is the lowest point is where it's at negative 2. So it's everything above negative 2. So the range is going to be y is greater than or equal to negative 2. Another way of saying this is in interval notation. We're going to start at negative 2 and go to infinity. Now, negative 2 is part of the graph, so we're going to put brackets around the negative 2. And then for infinity, we're going to put a parenthesis because we never reach infinity. Okay, so when I'm going from left to right on my graph, I'm decreasing here, and then I'm increasing here. So we're decreasing between negative infinity and negative 2. And then we are increasing from negative 2 to infinity. Now, on these, I have parentheses. parentheses are because I never hit any of the infinity or negative infinity. It's not part of my graph, so I always put a parenthesis whenever I write infinity. Now with 2, this point is not increasing and it's not decreasing. It's like half decreasing and half increasing. So we're also going to put parentheses on the 2 and negative 2 because they are not included in the increasing and decreasing. Now let's look at B. We're going to rewrite this in intercept or factored form. First we learn to add, then we learn to multiply. There's not a number in the front, so this is an easy blue. So we're going to take and factor it. We have an x and an x. We're looking for two things that multiply to 4 and add to negative 5. We've got 1 and 4 or 2 and 2. Since this is a negative number, the biggest number is negative, and since this is a positive 4, all the numbers are the same. So to get a negative 5, I'm going to use the negative 1 and the negative 4. Now to find my x-intercepts, I set each of these equal to 0. So I have x minus 1 equals 0 and x minus 4 equals 0. So x equals 1 and x equals 4 are my two intercepts. Now we're going to put these as a ordered pair, a point. So this is over 1 up 0. So 1, 0 and 4, 0 for the second one, for the second point. That's this point and this point. For our y-intercept, it's this point here, and we get that off of the standard form, plus 4. So this is our positive 4, so we have over 0 up 4. Our domain, it goes in both directions forever, so you can say all real numbers. You could use this fancy R to say all real numbers, or you can say from negative infinity to infinity would be the domain. It's everything in between negative infinity to infinity. Skip down to part C. Now, if we look at C, we have two square numbers. This is the difference of squares. So we have our x, we take our square root and our square root. So we have x and x. Square root of 9 is 3 and 3, 1 plus, 1 minus. You could say minus plus or plus minus. If I find my intercepts, I'm going to set both of these equal to 0, and I'm going to have negative 3, 0, and 3, 0. So if I set this one equal to 0, x plus 3 equals 0, I get a negative 3, which gives me this intercept. And if I set this piece equal to 0, x minus 3 equals 0, I add 3 and add 3, and so I get a positive 3 to both sides. My y-intercept I can get from the standard form. This number right here is my y-intercept at 0, negative 9. Now the domain is going from, it's all the numbers negative infinity to infinity. Now the range, we're going to start at the bottom, which is negative 9, and it's going everywhere up. Range talks about the y values. So we start at negative 9 and we go to infinity. Now negative 9 is part of the graph, so we're going to put a bracket on negative 9 and it goes till infinity, but we never hit infinity, so we put a parenthesis. For our increasing intervals, we're starting at 0 and we're going up, up, up forever. So from 0 to infinity, it is increasing in the x value. So here's where x is 0, and then until it just keeps going on forever. So we're going to put a parenthesis around 0 and a parenthesis around infinity. Decreasing, we're going from it's a very negative number. It keeps going in the negative direction forever. Negative infinity. Until we hit 0, is it decreasing. So negative infinity to 0. Now 0 is like half increasing, half decreasing. So it will, here's where x is 0. We always do put our x values. From negative infinity to 0, is it decreasing? And from 0 to infinity, it's increasing. But at 0, it's like half and half. Okay, now if we're looking at this graph, it's not an easy blue or a lightning red. It's not a difference of squares. We're going to look for our greatest common factor. Both of these have an x. We pull the x out, and then I have x minus 5. So if I want to find the x-intercepts, I'm going to set my y equal to 0, and then I set each piece equal to 0. So x equals 0, and x minus 5 equals 0, and so we add 5 to both sides, and x equals 5. So at 0 and 5 are where the x values cross the the x-axis. So we have the point 0, 0 as an x-intercept, and 5, 0 as an x-intercept. My y-intercept is right here at 0, 0. So my x and y-intercept are the same if it's at if it's at 0, 0. My domain is all real numbers, or negative infinity to infinity. Okay, on E, we're going to look at this. If it's a negative in the beginning, we always want to pull a negative out. So I'm going to start with a negative when I factor out, and they all have an x. So if I pull out a negative x, it's going to change all the signs on the inside, so we're going to have x minus 5. Now when I set each of these equal to 0, I have negative x equals 0 and x minus 5 equals 0. If I times both sides, or divide both sides by -1, I'm going to have x equals 0. I add 5 to both sides, and x equals 5. So at 0 and 5 are my x-intercepts. And if my x-intercept is 0, 0, my y-intercept is 0, 0. My domain is going to be all real numbers, or from negative infinity to infinity. And my range okay, looking at F, my x-intercepts, I want to factor this. So this is an easy blue. So first we learn to add, then we learn to multiply. Two things that multiply to 4 are 1 and 4, or 2 and 2. 2 and 2 are the ones that add to 4. So I have x plus 2 and x plus 2. Now if I set those equal to 0, x plus 2 equals 0, then we have only one intercept. Both of those equations are the same at -2. So I only have one x-intercept here. So I have -2, 0. My y-intercept, I look at my standard form, and it will be at 4. So 0, 4. My domain is going to be all real numbers. We can do like a fancy R for all real numbers, or negative infinity to infinity. My range is going to start at 0 and go up forever. So we could either say that the y is greater than or equal to 0, or it's going from 0 to infinity. Now we never hit infinity, so we put a parenthesis, and 0 is part of the graph, so we're going to actually put a bracket on 0. Okay, so for increasing intervals, we're going to start at -2 and go to infinity as our x values. So everything bigger than -2 will be increasing. So from -2 to infinity. And we never reach infinity, so infinity is always a parenthesis. And 2, at -2, it's half decreasing and half increasing. So we're going to put a parenthesis on -2. Now, it's decreasing everywhere less than -2. So we're going to start from negative, we always read a graph from left to right. So this is negative infinity until we hit -2. Now when we're looking at our standard form, that this last number, the constant term, is always going to be our y-intercept. This is only if it's in standard form. If it's in factored or intercept form, if we set them equal to 0, this will give us our x-intercepts. Okay, so if I have this factored form, I'm going to take each piece and set it equal to 0. So x minus 9 is 0, so I have one at 9, 0. And I add 1 to each side, I have 1 at 1, 0. These are my x-intercepts. Now, if I were going to try and find it in y-intercept, I would need to multiply this out. X minus 9 times x minus 1. And I would get x squared minus 1x minus 9x plus 9. And then when I simplify this, I get x squared minus 10x plus 9. And so this would be standard form. So this is going to be my y-intercept. And that would be at 0, 9. Okay, now here is just a bonus question. I'm going to have, if I set these equal to 0, I'm going to have x plus 1.6 equals 0. So if I minus 1.6, I'll get x equals negative 1.6. So this is the point right here is negative 1.6 comma 0. And then this is going to be, if I set this equal to 0, I'm going to have 1 at x equals 2. So this point right here will be the point 2, 0. So but then if I'm timesing it out, I get x squared minus 2x and plus 1.6x, that's minus 0.4x. And 1.6 times 2 is negative 3.2. So this point right here is going to be the point 0, negative 3.2. So A is 1, B is 0, C is 2, D is 0, E is 0, and F is negative 3.2.